Assalamu alaikum. This is MATLAB course lecture number 8. Today we will solve differential equations using the dsolve function with conditions, initial conditions, or without initial conditions. Actually, let me remind you what is the functions or the symbolic functions or symbolic equations. Just to remind you, CLC clear, close all. Say that I have a function, and this function value, the name of the function is y, and the value it is sine x plus x to the power 2. So how can I write this symbolic function or this function? We can write sims. We have a y, and y it is function of x. We can remove x if it is just one variable, but keep it like this better. Okay, sims y of x. Now we can say that y equal, if you remember, y equal to sine of x plus x to the power 2 like this. Okay, now how can I find, if you remember, how can I find the value of y at x equal to say that pi? We can write y at pi as example, just a variable name, equal to subs. It means I want to substitute which function y at which value of pi, 3.14, like this. So that now the y pi value will be calculated by substituting the pi value 3.14 in y function, and then we will get it. To display it, you can write print f function, and inside the message it should be like the following. Say that the y of this number, which is a float, equal to this number, which is another float. We can say that I want just two decimal places. Here. Okay, and then go to next line, and close the function from outside here, comma. We want the value, the first value, it is the value of say that the pi, okay, where the value is 3.14. The second value should be y of pi, like this. If I run the program, say that something .m, if I run the program, we will get a result. Now it's still busy. Now as you see, the y of 3.14 equal 9.86. How we got this value? By using the built-in function subs that works with symbolic equations or symbolic functions. Now how can I plot this function, the y function, without knowing the x values? If you remember, we have a plot function. The plot function itself, it needs the value of x and the value of y. In this case, we have to define x and find the y. But we have a function called f-plot function. This function accepts symbolic equations like y here. Like y, no need to indicate what is the value of x. It will make a general print or general plot for the y function. So this is f-plot, works with sims or symbolic functions. Now let me run again and wait for the result. This is y, and I'm waiting for the plot. I'll see, this is the plot for this function. Surely we can use hold on, we can use grid on, we can use axis, we can use title, x label, y label, if it is more than one drawing legend, and everything. Okay, this is just introduction. What is the symbolic functions or symbolic equations? So guys, now let me go back again to today's lecture. In today's lecture, guys, we will use the symbolic equations and dsolve function to solve differential equations, ordinary differential equations. As example, this is the equation, first order differential equation, dy over dt equal t multiply y. Now, as you see, it is a y function of time. So how we can start? By defining the sims. It is y function of t. Function of t. What is the value of y? Here, no need to define the value of y because I'm dealing with the first order linear ordinary differential equation. Now, how can I solve it? To solve it, we need also, just to remind you, we need also the initial condition. But let me solve it at the beginning without initial condition. Then I will get some constant inside the solution. So how we can solve this ordinary differential equation? We can write, as example, define this ODE by saying ODE. Just ODE, guys, it's just a name, variable name. It could be X, Y, Z, any name as you wish. We can say that ODE. We can say that ODE equal to. How can I say? If you remember, how can I say that dy over dt? Just to remind you, we have a diff function. It get the derivative of a function. Now, what the name of the function? Derivative of y. If it is first order, we can keep it like this or write comma 1. If it is second order, we can write comma 2, comma 3 if it's third order, and so on. So ODE equal diff of y. As you see, the left side of the equation here, it is dy over dt. So write diff of y. Now equal the value to the right side, t times y. It is t times y semicolon, like this. Now we defined this differential equation, ordinary differential equation, and we give it just a name, ODE, and it is equal to diff of y double equal t times y. So this equation now exactly written here, like this, and assigned to ODE. Now, how can I find the solution for ODE? We can write S solution as example equal to. Now we will use the dsolve function. What do you want to solve? I want to solve the ODE. Where is the ODE? Declared before. Now semicolon. I don't want to see the results in the command window. Save, run, and let us wait the solution. Now as you see, look to the workspace here. We have the t. As you see, it is 1 by 1 sims. Y, its function, symbolic function. ODE, it is 1 by 1 symbolic function also because the result will be symbolic function. And finally, the solution, it's 1 by 1 system or sim. Okay, now if you want to display it, let me write it in the command window here. Sol. See the solution, it is C3 times exponential of t to the power 2 divided by 2. This is why I told you if you don't have an initial condition, we will get a constant due to differentiation and integration. When you solve the ordinary differential equation, you need integration, you need many things. So at the end we got this constant. How can I find the value of constant? By the way, if you want to plot the solution, we will not able to plot. Why? Because we don't have the value of this constant C3. I will show you. Run the program now. We got error, and we don't have what is the because we don't have the value of the C3. Now, how can I find, before plotting, how can I find the value of C3? We have to use one of the conditions or initial conditions. So as example, I will solve it for say that assume that the value of y at t equal to 0 at t. Just to remind you, what is the solution? I will show you something. Solution. As you see, the solution, it is C3 exponential t to the power 2 divided by 2. Now imagine that t, it is 0. Time, it is 0. When time equal to 0, 0 to the power 2, it will be 0. Divided by 2, it will be 0. Exponential of 0, I forgot, wallah, exponential. It is 1, or I think 1. That's right. I think 1. So what's the value of C3? Imagine that we know that y of 0 equal to 1. Now Guys, this is a condition. How can I define the condition for this system? We have to say cond. Guys, cond, it's not a keyword, it's a variable name. It could be condition, co, x, y, z, any name, it's up to you. So just to remind myself, this is a condition. If there is more than one condition, write cond 1, 2, 3, 4. If it's just one, write cond. Or condition, it's up to you. Condition, cond equal y of 0, double equal to 1, like exactly what I did before here. So let me write this one before, cut here, write the ODE like this. So I'm defining the ODE. As you see, sims, this is definition for the ODE with the current, or say that the initial condition, and this is the solution. Now I want to solve using dsolve the ODE, comma, at the condition CO and D. Now the dsolve, if you have something here, the dsolve will know that this is the ordinary differential equation. And if there is a comma, something, it will know that this thing, it is a condition. Okay, so now I'm solving the same ordinary differential equation using a condition. So the solution now, it will not be, there will be no any unknown values or constants. Now, can I plot? Yes. Let me save, run the program, and wait. As you see, this is the plot for the solution of the ODE. And just to show you what's the solution, SOL, this is the solution. Exponential t to the power 2 divided by 2, and and if you remember, I approved that when t equal to 0, c will be 1 if the value of y equal to 1. Anyway, the initial condition should be known. It depends on the design, problem design, system design. It depends on the facts, sometimes scientific facts. It depends on the problem you have. So the initial condition should be known. This is how we can solve ODE with or without, say that, initial conditions. Now, how we can solve nonlinear differential equation with initial conditions or without? We have this problem, dy over dt plus y, all of them to the power 2 equal to 1. Now, exactly same, sims. Now, what is the variable, the function name? It is y. Function of what? Function of time. So keep it, y of t. ODE equal to what? We want to write this. It is the dy over dt, which is differential of y, diff of y, plus y, all of them to the power 2. All of them to the power 2. So this is to the power 2 like this. Equal to what? Equal to 1. The right side of the part, it is 1, like this. Now, this is the ODE. Again, ODE, it's not a keyword. It's a variable. It could be x, y, z, w, any name. But I prefer to use ODE because to remind myself that this is ordinary differential equation definition. And here, the condition y of 0 equal to 0. Y of 0 equal to 0. Keep it. Condition equal y of 0 equal to 0, like this. Now, this is the definition of the ordinary differential equation with the initial condition. How we can solve it? Same step exactly. Solve. Again, SOL, it is not a keyword. It is just a variable name. It could be solution, it could be S, it could be SOL, anything. Equal dsolve, it's a built-in function. It takes the ODE and the condition. Now we can plot same thing using fplot. Save, run the program, and let me show you the result. See, because here if you remember the ODE here, it is something to the power 2. That means we have two solutions. So as you see, this is the blue one, first solution, and the red one, it is the second solution. What is the solution? We can write SOL or use fprintf or display function. It's up to you. So see, the solution, it is exponential of minus t minus 1. This is the first one. Second one, it is 1 minus exponential of minus t. Next, how we can solve this ordinary differential equation? It is second order this time. Second order. Again, here we have y function of x this time. And the initial condition, it is y of 0 equal 1 and y prime of 0 equal to 0. The derivative of y at time equal to 0 or x equal to 0 equal to 0. Same thing, sims y of x. I will change t to x because y function of x here, not to t. Next step, the ODE equal the derivative of y, comma 2. And remove this one because I don't have it here. So d y, second derivative of y for x. Okay. Remove this bracket also. So differential dif of y, second derivative. This is the left side one. And at the right here we have cosine 2x minus y. Right here cosine bracket 2 it is 2 times x, 2 times x, and outside the cosine minus y. What's the initial condition? It is y of 0 equal to 1. So say that condition number 1, cond 1, again, cond 1, it is not a keyword, it could be any name. But to remind myself that I have two conditions, right, cond 1 equal y of 0 equal to 1, as you see in the question, equal to 1. And we need also the second one, say that cond 2, condition number 2 equal derivative of y at 0 equal to 0. What is dy? dy, guys, it is just a variable name or function name. What's dy? We have to define y. dy, sorry. So I can write here dy equal to diff of y. Diff of y, just the first derivative of y. Why? To use it here. Can I write it here, diff of y of 0? Yes, I can write, no problem. But I prefer to write it like this to make it clear. Now we have condition number 1, condition number 2. I will use them as a one vector. Say that this vector cond equal to the first element, it is the cond 1, then semicolon to go to next row. So we have column vector here, cond 2. Why? Because I have two conditions inside them, like this. Okay? So I have ODE and I have cond. Solution, same thing. Solution equal ODE, comma, cond. Cond here we have two conditions. The conditions should be arranged in a vector, column vector like this. Now same thing, solution. Let me show you what I will get. Run the program. We have a problem here in line number 6, column 22. Line number 6, column 22. Yes, it should be star 20. I think 2 star x cosine 2x. Save it, run the program again, and wait for the result. And please take care about this is the solution, the plot of the solution. And here, see in the workspace, we have cond, see 2 by 1 symbolic, cond 1 by 1 sim, cond 2 1 by 1 sim, dy, it is 1 by 1 symbolic function because it is derivative of the function. ODE 1 by 1 symbolic function, it is the ordinary differential equation definition. Solution, it is 1 by 1 sim also, it's an equation. X, it is 1 by 1 sim, and y 1 by 1 symbolic function because y function of x. Now if you want to get the sol, right, sol, enter C. This is the solution. We don't have constants here or unknowns. Why? Because we used by the way, guys, if we don't use the condition number 1 and condition number 2, we will get in the answer here, in the solution, we will get two constants unknown constants, two unknown constants, C1 and C2. How we can get them? We need two conditions. This is why I wrote here the condition number 1 and condition number 2. This is how we can write or solve the second order ordinary differential equation with initial conditions. Now the third order, as you see, du in this example, du to the power 3 divided by dx to the power 3 equal u. That means the third order differentiation of y versus x equal to u. And because here we have, it's a third order, we should have 3 constants in the solution. To solve for these constants, we need 3 initial conditions. They are given. Again, how can I solve it? again, sims, the name of the variable or the function here is y, u. U here function of x, keep it u of x. ODE equal to the third derivative of u, and double equal the value of u, like this. This is exactly just representation of this equation. Now we can say that we need du, the derivative of u, and we need the second derivative, say that ddu equal, because we have here, I'll see, in the conditions we have u of 0 equal 1 and u prime of 0 equal 1 minus 1 and u double prime equal pi, second derivative. So du, it's the first derivative. ddu, say that it is the diff of u, but it is second order, the second derivative. Okay? Now we have three conditions. Say that cond 1, when time or x equal to 0, u of 0 equal to 1. And condition number 2, du, the derivative of u, when x equal to 0, it is equal to minus 1. So equal to minus 1. And we can repeat Ctrl C, Ctrl V, the third condition. Say that cond 3, okay, the condition number 3 equal ddu, the second derivative of u, when x equal to 0 equal to pi. So I will change minus 1 to pi, which is 3.14. You can declare pi before and use pi name. Now cond equal cond 1 semicolon, cond 2 semicolon, cond 3. Again, cond, it's not a keyword. It's just a variable name. You can use any name as you wish. Now solution, the solution equal to desolve the ODE, comma cond. And again, we have to plot the solution. Let us see what will be the solution. We have problem, undefined function of variable y. It is in line number 7. Here, yes, it should be diff of u, not y. Run the program again and wait for the solution. Yes, see, this is the graph of the solution. And here is the values, and if you want to display the solution, write sol here to see the solution. As you see, in the solution, it's supposed that we have three constants, unknown constants, but because we have three initial conditions, we know these constants. Next, how we can solve system of differential equations. As you see in this example, we have du over dt equal 3u plus 4v, dv over dt equal minus 4u plus 3v. So we have two functions here, u and v, and both of them function of time, and we have two differential equations here, two ODEs. So again we start again, same steps, sims u of t, not x this time, and we have the other one v also function of time, Now let us write the first ODE. We can write ODE1. Again, ODE1, it is not a keyword, it is just a variable name. You could save it UOD as example, anything. I will write it ODE1, that's it, okay? Equal du over dt, it is the first derivative of u. You can write 1 here or remove it, it's up to you. And it is equal to 3u, 3 times u plus 4 times v, plus 4 times v. And we have to write the second ODE, because we have system of ODE here, ODE2 equal diff of v, this time v. Okay, can I write diff of u comma t? Yes, it could be. That means I wanted to differentiate u for t, but keep it like this, no problem. Diff of v, and it is equal minus 4 u plus 3v. So we have now the ODE1, ODE2. Now let me define the ODE. Say that ODE equal to, again, like the conditions, we have the ODE1 in the first column, semicolon, ODE2 in the second one. So now this is the system of ODEs. Now again we have initial conditions here. I will solve them without initial conditions, guys, okay? So let me write all of these, make them as a comment. or delete them, no problem. Delete them or comment, no problem. And condition here, same, comment. Okay. Next, we want the solution without knowing say that without the initial conditions. So solution equal dsolve ODE at conditions. Remove conditions because I don't have them. Save. Now I'll see again ODE1, ODE2, and we have, I'm sorry, this should be not commented like this. ODE equal ODE1, semicolon, ODE2. So solve, dsolve, ODE, run the program. But it's by mistake. I should not plot because here we have two things inside. I will show you. Run the program again. It is finished now. As you see, again, V, it is 1 by 1 symbolic function. U, 1 by 1 symbolic function. T, it is the symbolic value. Now see the solution. Now the solution, it is 1 by 1 structure. ODE1, it is 1 by 1 symbolic function. ODE2, 1 by 1 symbolic function. And ODE, it is 1 by 1 sim function. Same thing. Now see the solution. Double click on the solution. It's a structure. 1 by 1 structure. What's inside the structure? We have the value of V, the value of U. Open the V. This is the equation of V. See, we have a constant here, 1 and 2 constant. So to solve for V, we need two initial conditions for V. And same thing for U. We have another constants or same previous constants. Anyway, so we have to introduce the initial conditions in order to find the solution. Imagine that as example, I don't know exactly, let me open again the value of U, the solution of U and solution of V. So we have cosine and exponential, sine and exponential. So when that time equal to 0, we can get a result. It's okay. So let me now say that the initial conditions, we need two initial conditions. Say that as example, we need condition number 1, we need condition number 2. Say that condition number 1, the value of U at 0 equal to 1, and condition number 2, the value of V at 0 equal to say 1 also. Okay, now I will remove this one and say that cond equal condition number 1, semicolon, condition number 2. Remove this one, no need for it, like this. Now the ODE, the solution equal dsolve ODE at conditions, cond. Okay, now let me run the program and show you the result. Now we got the result, solution. We have the U value. See, we don't have here, I see in the V value, we don't have a constant because we have two initial conditions. We have the initial conditions. Now, how can I plot? Them? Before plotting them, how can I show the value of U and V? Remember, it is SOL structure. That means we can write SOL dot U and SOL dot V to show them. Let me delete them from here, and I will do them here. I will write SOL dot U. It shows you the solution of U. Write SOL dot V because structure. See the answer, it is cosine. How can I plot them? Both. In one figure, we can say that f plot, the first one, which is solution dot U, f plot U. Okay, then we need hold on to keep them in one figure. Now f plot, I will write solution dot V, and surely you can use legend. Say that the first one, it is the value of U, and the second plot, it is take care, the value of V. It depends on the order you plotted it. It's okay, and you can say that a grid on, title, label, everything. Run the program, and let me show you what is the figure. I'm still waiting for the figure. I see this is the figure. See, the red one, it is the value of v, and the blue one, it is the value of u. As you see, the value of u and v, they are same from 0 until reach time or around 3. Then there will be a difference between them. This is how we can solve system of linear equations. Now, how we can solve linear or say system of ODEs, but using a matrix form. Sometimes matrix form will be better than the previous one, but both of them works well. Never mind. But say that we have this two ODEs, ordinary differential equations: dx over dt equal x plus 2y plus 1, and dy over dt equal minus x plus y plus t. Now, the matrix form, we want to rearrange this equation. Now we have x and we have y, and both of them function of t. So we can say that here, the left side of the first equation, it is x prime, as you see here. And the second one, it is y prime, as you see here, equal to, so I will put them, the first one here and the first one here, I will put them in a vector, x prime, y prime, each one in a row, equal to some matrix. This matrix multiplied by x and y. As you see here, we have x to the right side, and here we have y. Here we have x and we have y. Now, the 1, it is the coefficient of x, the 2, coefficient of the y in the first equation. The minus 1 here, it is coefficient of minus x, and 1 here, it is the coefficient of y in the second equation. Now, plus constants. The constants, they are 1 and t. So 1 and t, and remember, it's plus, not equal, because here we have plus, here we have plus. So exactly, this is the form or representation of these equations as a matrix form. Now let us say that y capital equal x and y vector, a capital equal this matrix, and b capital equal the constant vector 1 and t. So the equation now, it is y prime, because we have x prime, y prime here, y prime equal ay plus b. Now we want to solve this equation, y prime equal ay plus b. Before that, what we should do, we can write sims. Here we have say that we have x and we have y, and both of them function of t. Okay, we can say that y equal, it's a vector of what? Y capital, it's a vector of x, semicolon y, each one in a row. Okay, and then we can say that a equal to the matrix, we have 1, 2, semicolon, to go to the next line, minus 1, space 1. This is the value of A. And we need the value of B. B, it's a vector. We have 1, semicolon t. So this is the vectors and matrices definitions. Sorry, this is not double equal, 1 equal. Like this. Okay, so we have y capital A, B. Okay? Now, the equation, we want to write the equation in a form. So ODE, we can write ODE. Let me delete all of these because we have just one ODE. Say that ODE equal, as you see, it is y prime, which is diff of y capital. Take care, because we have y small and we have y capital. Y capital, it is the vector containing x and y small. So diff of y, and equal to a capital times y capital plus b capital. We should give the initial conditions. Say that we don't have initial conditions, so I will make these as a comments, and I will write sol equal dissolve the ODE without conditions this time. Okay, and let me not plot. I will make comment to show you. Run the program. See, we got the answer. Solution. Inside the solution, we have the value of y, we have the value x. If you want to show the x value, write sol, because it's structure dot x. This is the value of x. See, we have here a constant. I don't know exactly how many constants we have. Maybe 1, maybe 2. It depends on the order. I have just one here because it's first order, I think. Okay, the value of y, sol dot y small, not y capital. Y capital containing x and y. Okay, that means we have, as you see here, we have C17 constant, here C16. So we need two initial conditions to solve for two constants. As example, say that condition number 1 and condition number 2 conditions. Say that I have the value of x at 0 equal to 0 as example, and the y at 0 equal to 0 also. Cond equal cond1, cond2, solution equal dissolve ODE, comma, cond. Okay? Then if you want to plot the value of x and the value of y, same story. You write sol.x and sol.y here and change the legend from x to x and y. Save, run to see the result. As you see here in the result, the x it is in the blue, the y it's in red.